At the end of this video, you should be able to relate the concepts of energy, time, and power, calculate power in two different ways, and explain the effect of machines on work and power. Chapter 5, Section 4, Power. Rate of energy transfer. The rate at which work is done is called power. More generally, power is the rate of energy transfer by any method. Like the concepts of energy and work, power has a specific meaning in science that differs from its everyday meaning. Imagine you are producing a play and you need to raise and lower the curtain between scenes in a specific amount of time. You decide to use a motor that will pull on a rope connected to the top of a curtain rod. Your assistant finds 3 motors, but doesn't know which one to use. One way to decide is to consider the power output of each motor. If the work done on an object is W in a time interval T, then the average power delivered to the object over this time interval is written as is shown on the screen here, where power is equal to work divided by time. It is sometimes useful to rewrite this equation in an alternative form by substituting the definition of work into the definition of power. The distance moved per unit time is just the speed of the object. The SI unit of power is the watt, represented as capital W, which is defined to be 1 joule per second. The horsepower, represented as HP, is another unit of power that is sometimes used. 1 horsepower is equal to 746 watts. The watt is perhaps most familiar to you from your everyday experience with light bulbs. A dim light bulb uses about 40 watts of power, while a bright bulb can use up to 500 watts. Decorative lights use about 0.7 watts each for indoor lights, I should say, and about 7.0 watts each for outdoor lights. In sample problem F in this section, the 3 motors, which we referred to earlier, would lift the curtain at different rates because the power output for each motor is different. So, each motor would do work on the curtain at different rates and would thus transfer energy to the curtain at different rates.
Power is a measure of the work done or the energy transformed per unit time. Power is the rate at which work is done or energy is expended. It is measured in joules per second, which are known as watts.
At this point, you should be able to relate the concepts of energy, time, and power, calculate power in 2 different ways, and explain the effect of machines on work and power.